Welcome to homework.
Problem 11.29. So we have an art installation where we have an aluminum sphere. It's being hung from a steel wire that's a ½ meter long and has 2.5 times 10 to the negative third centimeters squared cross-sectional area. The mass of our aluminum sphere here is 6 kilograms, and we're going to call its wire and this 1. And from that, we have the same length and diameter of steel wire that's supporting a brass cube that has a mass of 10 kilograms. And so first we want to find the tensile strain in both wires, and then the elongation in both wires. So to find the tensile strain, first we have to find the tension. We'll start with 2 first because there's less going on here. There's just the weight of there's just the weight of the brass cube. So T2 equals M2G. And so this is 98 newtons. So here we have basically just the weights of both of these things. The weight of this is transmitted through tension. We already found tension number 2, so that's convenient. And we know that, so then we know that T1 minus T2 minus M1G equals 0. These are both derived from the equilibrium conditions. So just adding these two things to both sides and then plugging in the numbers, we find that the tension in wire 1 is 157 newtons. And you would expect it to be higher because it's supporting more weight. So from our equation for the Young's modulus, we know that this is the stress divided by the strain. Sigma is the symbol used for stress, and epsilon is used for strain. And so the strain in wire 1 is going to be, and so then this is going to be the stress in wire 1 divided by its Young modulus. And so this is 157 newtons. The stress is the force divided by the area. Then converting that to square meters is 2.5 times 10 to the negative 7th meters squared, and then the Young's modulus of steel is 200 gigapascals, or 2 times 10 to the 11th. And so the strain, which is dimensionless because we have newtons per meter squared here and then newtons per meter squared here, it's going to be 3.1 times 10 to the negative third, so something like 0.3%. Strain 2 a little more like an epsilon. Doing the exact same thing, but with the the tension in the second wire gives us 2 times 10 to the negative third. Now B, the strain is the elongation divided by the initial length. We want to know the elongation. The initial lengths of both of these things are, 0.5 meters. So for the upper wire number 1, you get 1.6 millimeters. And for the lower wire number 2, you get 1.0 millimeters. And so this all makes sense, like we said when we were computing the tensions, because this is supporting more forces, more due to the weights of these things than this one is, which was only supporting the brass cube.